So here enantiomer in the carbohydrates, enantiomer in carbohydrates. What is the part from this enantiomer? This is the basic of enantiomer. As we know, this is the isomer. The concept of the isomer having this is the two types. One is the constitutional isomer, as you can say this is the structural isomer, and what structural isomer and stereo isomer. So that is the part of the stereo isomer having the two parts, again what a geometrical isomer and what optical isomer. So the part of optical isomer, the concept of the optical isomerism, that is what a plane of the source of light is passed through nickel prism, and which will obtain this is a single line, and that single line is nothing but what a plane polarized light. So that plane polarized light is passed through the organic solvent. If the organic solvent is the asymmetric, as you can say this is the chiral or optically active. When we can say this is optically active, this organic compound, or this is the for example we can take this glucose molecule or the glyceraldehyde. This compound containing the chiral central, compound containing at least one chiral center, it means it is nothing but one asymmetric carbon atom, and which will be obtained. This is the rotation, that is the clockwise direction and anti-clockwise direction. This clockwise direction is nothing but dextro rotation, and anti-clockwise direction is nothing but leo rotation. So here that is the dextro rotation. You can see this is the relative, as you can see the relative configuration and what absolute configuration. So this absolute configuration, you can say this is the R and S concept. Here rectus and sinister. Because in relative configuration, that is nothing but what capital D, small d, and L, and this is nothing but dextro and leo concept. So dextro leo, it is nothing but what, as you can say this source of light is passed through this is nickel prism, and this nickel prism which will obtain this nickel prism, this is the plane polarized light, this is the single is a PPL, plane polarized light is obtained, and we pass this is the organic solvent. If the organic solvent is optically active, it is nothing but, for example this types of the compound, this is nothing but what a glyceraldehyde. So these types of the glyceraldehyde, as you can say this is the COOH, again this CH3OH, and this is the hydrogen atom, and this is CH3. So lactic acid. So part of this is the lactic acid or glyceraldehyde. It is nothing but one of the chiral center, asymmetric carbon atom. Then it will be obtained. This is the two direction of the light. It will obtain what two direction of light. This is nothing but what clockwise direction, and another is what anti-clockwise direction. So this clockwise direction is nothing but dextro, and anti-clockwise direction is nothing but LEVO, leo rotation. This will be obtained 50% dextro and 50% leo. So thus these types of the molecule is nothing but what optically active. So तो इस molecule को क्या कहते हैं, optically active molecule कहते हैं, because this is going to the formation of the enantiomer, not super impossible mirror to each other and having the enantiomer concept. तो ये molecule यहाँ पे क्या हुआ, glyceraldehyde और lactic acid, as you can see this is the glucose molecules are optically active, so that is nothing but enantiomer. तो ये concept हमको यहाँ पे explain करना है, enantiomer in a carbohydrate. So what is the concept of the enantiomer in the carbohydrates? So the compound which possesses non-super impossible. So for example we are having the types of the molecule in nothing but glyceraldehyde. हमारे पास glyceraldehyde है. This is nothing but C double bond OH. This is the types of the hydroxy group at the right hand side, and this is nothing but what CH2OH. It is nothing but these types of the molecule is the glyceraldehyde. What is that? Glyceraldehyde. तो ये glyceraldehyde है. So these types of the diglyceraldehyde, as you can say. So why it is known as diglyceraldehyde, and when we call it is the diglyceraldehyde. So for another types of example, this is nothing but so this is the glucose molecule. For example, this C double bond OH, and which are having this what CH2OH. Suppose these types of the hydroxy group on the right hand side. This is what it is indicated. These types of the glucose molecule 1, 2, 3. This is the RS. This is the hydroxy group is the left hand side, right hand side. This is the position of the hydroxy group. So these types of the molecule is nothing but glucose. As you can say, this is the carbohydrate monosaccharide. This is C6H12O6. C6H12O6. This is the molecular formula of glucose molecule. So these types of the molecule is nothing but glucose. Which types of the glucose molecule, and when we call it is the diglyceraldehyde and D-glucose and N-glucose. So another types of the compound we can write this is the CHO. Again, this hydroxy group on the left hand side, this hydrogen atom, this CH2OH, 1 number, 2 number, 3 number. So this hydroxy group position is as it is, there is no change of this hydroxy position. So this is nothing but what? As you can say, these types of the carbon atom, whenever this bottom, this hydroxy group on left hand side. So this hydroxy group on the right hand side. So that is the indicated. This is nothing but dextro. So as you can say, say this is the diglyceraldehyde. तो इसको कैपिटल diglyceraldehyde कहते हैं. Suppose the hydroxy group and what happened, we can say this one hydroxy group, the same types of the compound is in the water, non super impossible very much. So this one one of the hydroxy group, and this not only here but also we can say this the types of the compound is on hydroxy group is here, and this CS2OH is as it is. So if we have to look in these types of the molecules in a mirror image, so what happen, this diglyceraldehyde is having this the L capital L, this is the glyceraldehyde. तो ये हमारा कौन सा कंपाउंड हुआ, glycerol. This diglyceraldehyde and this one is L glyceraldehyde. Diglyceraldehyde and L glyceraldehyde have both. What is the relation of this diglyceraldehyde and L glyceraldehyde? First of all, what do you mean by the D? The D is hydroxy group on right hand side, and L it is the hydroxy group on left hand side. So ये हुआ हमारा diglyceraldehyde, ये हुआ हमारा L glyceraldehyde. diglyceraldehyde का कहना है कि जब hydroxy group right hand side पे है, so this chiral center, this is the chiral center. These are optically active compound asymmetric molecule which shows the dextro and neo rotation, and this types of the molecule is the relation in the mode of non super impossible. इसका relation क्या है, non super impossible mirror है, non super impossible mirror image, and this is nothing but the relation is what enantiomer. So this is nothing but enantiomer. If the molecule is the right hand side, this types of the configuration order 1 2, this is the order R configuration, and this types compound is in the order S configuration. The relation it shows this R to S, or we can say S to R. So these types of the relation in the order enantiomer to each other. तो ये एक दूसरे का क्या relation हुआ, enantiomer हुआ. So same types of these types of the compound in the order hydroxy group. These types of the hydroxy group order left hand side, right hand side. So this is the order D-glucose. As you can say, this is the D-glucose. Whenever this hydroxy group and left hand side of this which of the bottom of this is the primary alcohol. So these types of the molecule is the order L. You can say this is the L-glucose. So these types of the relation of the D-glucose and L-glucose. What is the relation between the D-glucose and L-glucose? Again, what are it is the enantiomer together. This is non-super impossible and having the enantiomer. So these compounds showing these types. If you are having these types of the carbon atom, if this is the R configuration and it shows what a S configuration. Again, we can say R to S, R, S to R. This relation of these two molecules to each other, दो मॉलिक्यूल का इसमें रिलेशन होता है enantiomer. ये क्या होते हैं आपस में, नॉन सुपर इम्पॉसिबल होते हैं. So this is nothing but a relation, as we can say enantiomer in what carbohydrate, especially this glyceraldehyde, and what, and we can say this another example, glucose molecule.